Today we are looking at function operations. This is where instead of just adding, subtracting, multiplying, dividing, just numbers or simple expressions, you actually have binomials or bigger. You're doing some of the same stuff. And so just as a reminder, when we have this f parentheses x or g parentheses x, or any other letter with a parentheses and another letter, that's called function notation. And we treat that's the same as saying the y equals f of x, g of x. It replaces the y in our linear expressions, or quadratics, or whichever type of expression or equation we're looking at. So this is called function notation again. And so this does not say f times x, it's just f of x the way we write it. Okay? And so if we look at this first problem here, first thing that I look at when I see this is what do you think f plus g of x is actually going to do? And it's pretty a simple thing. It's going to take those two functions, f and g, and add them together. And so what we end up having is 3x plus 8. That's the f of x part. And that's the f part. And then plus the g part, which is 2x minus 12. And so to get my solution, all I'm going to do is combine like terms at that point. 3x plus 2x is 5x. 8 minus 12 is minus 4. And so that is the solution to f plus g of x when f of x is 3x plus 8 and g of x is 2x minus 12. So again, this part, and the first part of your assignment you're going to be doing is the same setup where all you're going to do is add, subtract, multiply, or divide the functions. Okay? The division will be a little bit harder than the others, just because division with functions is a little bit more difficult, but the rest of it should be pretty simple. Okay, so if we added the two functions when we did f plus g of x, when we do f minus g of x, we're going to do the same piece. We're going to subtract the two functions. But because of subtraction, we do need to use parentheses now. So f is 3x plus 8 minus g is 2x minus 12. So it's that same process. You have f minus g, and so what we're going to do is subtract those, but it's a combining like terms thing again. So we have 3x minus 2x is just x, and then 8 minus negative 12 is a positive 20. So we end up with x plus 20 in that. So adding and subtracting, you just add and subtract the two expressions. Notice that I did list f first on both of these, here and here, because f was first over here. Now when we get into doing what's called composition of functions here in a few minutes, the thing that's second is actually going to be the thing you do first, but we're going to talk about that as we get there. So, when you're just adding, subtracting, multiplying, dividing functions, you'll take the first function, which in this case was f, both of these, and then you add or subtract, multiply or divide to that one. And so in the multiplication, same exact process. We are going to take f, which was 3x plus 8, times g, which is 2x minus 12. So this one we have to distribute. Use the old FOIL method if you remember it. So you got 3x times 2x, which is 6x squared. 3x times a negative 12, which is negative 36x. 8 times 2x is a positive 16x. And 8 times negative 12, which is a negative 96. And then again, you combine any like terms you can. So So we have 6x squared minus 20x minus 96. And there's my solution to the multiplication problem. On the division, sometimes the division is actually pretty simple, and this is one of those. You just write the division as f over g. And if there is a way to divide or to factor something out that'll divide, then you can. But like on that top expression on f, 3x plus 8, there's nothing I can factor out of that, so there's nothing I can divide it out of in the bottom either. So on this one, this ends up being my solution. All right, so the add, subtract, multiply, and divide functions using function notation. Just remember that this here, that does not say that I'm multiplying f over g times x. That is not what it's saying. It's just that function notation of some variable of x. And so that's kind of what we're dealing with. In this case, we're using f and g. I think you'll see h sometimes used. And any variable can be used, but those are usually the most common variables. All right. So now we're going to move on to the next piece, called composition of functions. Okay. Let me make this a little bit better here. Okay. What we have here, it says g with that little bitty circle, and then an f, and then of x. And so what this ends up saying, that little circle is kind of like a degree symbol, like when you do degrees Fahrenheit, with that little bitty circle, but it's not up, it's kind of in the middle. Okay? And that's just it's that composition piece. It's what we're going to talk about here is composition of functions. And so this says, verbally I say g of f of x. So there's a couple of ofs in there, and what that means is we're going to use this new function that we've created where we do f of x first. And these two things mean the same thing. So we're going to do whatever's closest to x here, we do that one first. And then once you have done that, then you evaluate the g part second. Whichever one's furthest away from the x. So in this case, the g. Okay, when you flip it down here, when we get to this green part, notice we'll do g first and then do f because of the order change. Okay, and so, all right, so we're looking at this problem here. Let f of x equal x minus 2, and let g of x equal x squared. And it says find g of f of negative 5. Okay, so what we were told up here was we evaluate the thing that was closest to the x first. So we're going to evaluate f of x first. So in this case, we're going to evaluate f of negative 5. So f of negative 5 equals, and what that means, I'm going to take that negative 5, and I'm going to plug it in for x in the f of x expression, or the equation. Okay, so instead of x minus 2, it's going to be negative 5 minus 2, and I'm just going to evaluate that, which is negative 7. So we found f of negative 5, so that's what we start with. So then we go to the g, and g of f of negative 5. So we found f of negative 5 was 7, so we're going to find negative 7. So we're going to find g of negative 7. So we're working our way out. Okay? And so the g of negative 7, g of x is x squared. So that's going to be negative 7 squared, which is a positive 49. So our solution there is a positive 49. So kind of talking back through it again real quick. Okay. You start out finding whatever's closest to this function here, negative 5 in this case. You start out finding that function f of negative 5, and you plug that negative 5 in for x in the f function. Okay. Then once you have found that value, you take g of that value. So I'm going to plug that negative 7 up here into x for g's function. So we're going to do the same process, but we're going to flip it around and we're going to find f of g of negative 5. So this time the g is the one that's closest to the negative 5. And so we're going to find g of negative 5. We're using the same f and g that we used a while ago. So g of x is still x squared. So this time, instead of x, we have negative 5. So g of x is negative 5 squared, which is 25. So now, when we find f, we're finding f of that value we just found. So f, we're going to find f of 25. And if we go back to what f is x minus 2. So that's 25 minus 2, which is 23. So we have now found our solution there. F of g of negative 5 is 23. Let's do one more. This time we've changed what f of x and g of x are. F of x is now x to the third power. G of x is now x to the second plus 7. Okay? So in this problem we're finding f of g of 2. So we're going to take the thing that's closest to that 2, which is g. So we're going to find g of 2. So we're going to replace x with that 2. So 2 squared plus 7. And 2 squared is 4. 4 plus 7 is 11. So next we find f of 11. And f of x is x to the third power. So all we're finding is 11 to the third power. And if I remember right, and I plug this in, I think that is 1331. So 1,331. Yep. See how that is the process. It's not difficult, but it's just a constant kind of rethinking your brain again. So that's the setup. The assignment is down here at the bottom. Okay, it's page 394 through 395, 2 through 42 even. So you have 21 problems. Some of these are pretty simple. Some of them take a little bit more time, but not a long time. And it is due on Monday. We will have our STAR test, I think, on Friday is what it's looking like. And then next week we will finish up the semester with logarithms. So if you have any questions, let me know.